We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing Chandra does is take these superb, sharp images.
Starlight, Starbright, first star I see tonight. Looking at the light from stars is exactly how astronomers can learn about them. But stars do not just give off the type of light we can see with the human eye. Astronomers need to study stars in many different types of light, including X-rays, to really understand them. Dr. Nancy Brickhouse studies stars with the Chandra X-ray Observatory and other telescopes and instruments. She explains some of the basics of what stars are.
A star is a ball of hot gas, and in the center it's very, very dense and producing nuclear fusion reactions, and that's what makes the star hot. As you go out into the atmosphere of the star, eventually you reach what we call the photosphere, which is the surface of the star. The visible light color of the star is actually coming from the photosphere.
Even though that might sound straightforward, there's really nothing simple about stars. To begin with, there are many different kinds. Huge red stars called red giants, small hot white stars called white dwarfs, small cool brown stars called brown dwarfs, and even more. Dr. Brickhouse explains how astronomers can keep track and categorize these very different objects.
Stars have a temperature that's related to the color of the star. So the blue stars are hotter than the yellow and red stars. We have a classification scheme that's going from hot to cool, and the sun is considered to be a cool star. This is based on visible light properties. The color is related to the temperature of the photosphere. When we look at these stars in X-rays, we're looking above that surface. So we're looking higher up in the atmosphere of the star, where the gas is really not as dense, but it's much hotter. Both hot stars and cool stars make X-rays, but the processes are different. So when we look at the cool stars, we're looking at processes that are more like the sun.
Where does our sun fit into the scheme of things? What does Chandra and its X-ray data tell us about our nearest star?
We can look at the sun with other satellites, and there have been X-ray missions for just studying the sun. It would wipe out Chandra's detectors if we use Chandra to look at the sun. But we can study other stars, and it turns out that 10 to 100,000 times more energy is produced in X-rays than what the sun produces. By the standards of other stars, the sun is actually kind of a wimpy X-ray producer.
Astronomers can't use Chandra to study our sun directly. What kind of insight do astronomers get by studying other sun-like stars using Chandra? It turns out to be a very valuable thing to do.
One of the reasons to look at other stars is to get some understanding of what the processes are that cause the X-ray emission and what kind of diversity there might be, because it will help our models. If we just have one system to look at, even though we can look at it in a lot of detail, we don't necessarily understand the possibilities that would help us constrain our models.
Studying all kinds of stars, including those like our sun and those that are very different, remains an important area of research in astronomy and astrophysics. The starlight we wish upon in that rhyme turns out to be much more complicated and informative than we may have ever expected. Researchers using Chandra are helping to address some of the questions whose answers may only be found in their X-ray light. For more information about the Chandra X-ray Observatory, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.